Let's use rigid motions to determine if triangles are congruent. Number 1. Determine if triangle ABC and triangle GHI are congruent. We are going to check if these two triangles are congruent using these two rigid motions below. We're going to rotate and then we are going to reflect. Step 1. Apply the first rigid motion to the pre-image. Our pre-image points are A, B, C, and here are the ordered pairs of where they're located. To apply the first rigid motion, we are going to take the x and y coordinates and send them to their opposites. So A will go from a -5, -3 to a +5, +3. B will go from -2, -8 to +2, +8. And C will go from a +8, -6 to a -8, +6. Here is A at -5, -3, and it goes to now +5, +3. B will go to +2, +8, and C will go to -8, +6. This is the image after rotating triangle ABC 180 degrees about the origin. How did we apply the first rigid motion? We applied the first rigid motion, rotate 180 degrees about the origin, using the rotation function, using the specific rotation function for this rigid motion, and taking the ordered pairs of our previous triangle and finding the new ordered pairs for our image. Step 2. Apply the second rigid motion to find the final image. We're now going to take our triangle after rotating and reflect this triangle across the line y equals x. To do that, we're going to take the ordered pairs of this previous triangle and we are going to swap their locations. 0.53 becomes 3,5, 2,8 becomes 8,2, and -8, +6 will become +6, -8. If we watch these points now move, we're going to have the 0.53 go to 3,5. We have the 0.28, and that will now come to 8,2. And we have the point -8, +6, and this is going to travel to +6, -8. How did we apply the second rigid motion? We applied the second rigid motion in the same way that we did the first. We took the three ordered pairs of the previous triangle, applied them to our specific reflection function for a reflection across the line y equals x, and we got our new three image points to construct our new triangle. Step 3. Determine if the triangles are congruent. These final 3 points ended at specific locations. The point 3,5 is the same ordered pair for the vertex of G. The point 8,2 is the same ordered pair for the vertex H, and the ordered pair +6 and -8 is the same ordered pair for the vertex I. So we can now conclude that triangle ABC is congruent to triangle GHI because the shapes perfectly overlap after 2 rigid motions. How did we determine if the triangles are congruent? We determined that the triangles are congruent because after our 2 rigid motions, our final ordered pair vertices matched up perfectly with the triangle we were testing for congruence, which was triangle GHI. You are now ready to use rigid motions to determine if the triangles in problem number 2 are congruent.